Welcome to Module 2. Module 1 was about amps or amperage. Amps in electricity is the amount of electricity passing a certain point at a certain time. It is the amount. It's what'll kill you, the amperage. This module, we're going to talk about voltage. Voltage is the push behind the electricity. So let's go ahead and begin Module 2. So the first thing we want to talk about in this video is electromagnetic force. We want to distinguish it from voltage. Now, to me, they're mostly the same. It's a fine distinction between electromagnetic force and voltage. There is a mathematical difference. We're not going to worry too much about electromagnetic force. We're going to worry more about the voltage. But what is electromagnetic force? Well, electromagnetic force has to do with the force coming from the source of electricity, say a battery. It's the force ready to push the electrons through the circuit. We sometimes say EMF, electromagnetic force, EMF for short. Now, I don't know if you know the Kentucky Derby or if you're into horse races or anything like that, but before the race begins, all the horses, they're in their stalls, they're ready to run, they're primed. I mean, they're going crazy. Let me out, let me out, let me run, let me run, let me run. You know where the goal is, you know where the end of the race is. The horses are primed. Let me out, let me out. Electromagnetic force is kind of like the potential for force that a source of energy has, like a battery, before the circuit is connected. So let's say the circuit is an open circuit. The switch is not connected. There's no electricity flowing. But the electrons are like, let me at him, let me at him, let me out, let me run, let me run. The electromagnetic force, the EMF, is the potential for force coming from a source like a battery. Could be a magnetic source as well, like a magneto or something like that. But the electromagnetic force is the potential for force, electromagnetic force, electricity force coming from the source. It's ready to push the electrons through a circuit. It's slightly different from voltage in the sense that voltage doesn't necessarily relate to the source. Voltage is this potential difference in how much how much force it has as it goes through. So like the horses in the Kentucky Derby, they have a lot of energy when they start, and frankly, they have a whole lot of energy the whole way through. But this may not be technically correct, but think of it as every time the electricity hits a hurdle, every time the electricity hits a resistance, like a light bulb or something like that, it loses a little bit of its force. And then it loses a little bit of its force. And then when it gets back, it comes out of the negative side of the battery and comes back to the positive side of the battery. You might think about when it just barely crawls across the finish line when it gets back to the battery. It's used up all of its force potential by the time it gets back to the battery. The voltage is the force it has at any particular point between 2 points, as it were, anywhere along that circuit. But anyway, I think you'll do just fine if you think of voltage as the push of the electrons. 1 volt is the amount of push it takes for 1 amp of electricity to flow through 1 unit of resistance. We'll do resistance in the next unit, the next module, and we'll learn that the unit of resistance is the ohm, OHM, named after a guy. So 1 volt is the amount of push it takes for 1 amp to flow through 1 unit of resistance. All the prefixes we learned about amps apply. So you have volt, but you also have a millivolt, which is 1,000th of a volt. You have a microvolt, which is 1,000,000th of a volt. So milli is 10 to the minus third power, 0.001. Micro is 10 to the minus sixth power, 0.000001. Kilo is 1,000 volts. A kilovolt is 1,000 volts. A megavolt is 1,000,000 volts, and so forth. So all the metric prefixes we learned in the previous module apply to volts as well as to amps. Well, a little bit about the conventional battery. Of course, we've gotten very creative with batteries these days, but you can still go to a Walmart and buy a battery that looks a little bit like this. What's inside that thing? Have you ever tried? Don't do it. You'll get chemicals on yourself. But basically, a battery uses chemical energy in order to produce electrical energy. It has a positive terminal, which is called the cathode. The way I remember it is cats are positive, which of course they're not. Cats are perhaps the most negative domestic animal there is. Anyway, see all the memes about cats and dogs. So cats are not really positive, but I don't know. That's the way I remember it. Cats are positive. So the cathode is the positive terminal. It's often made out of something like graphite or carbon or something like that. And so the electrons go into it. Outside of a circuit, electricity, as we said in the previous module, electricity flows from the negative terminal around the circuit and back into the positive terminal. So the horses come out of the negative terminal. The electrons go into the positive terminal. So the cathode is the part with the little thing, knob on the top sticking out of the battery. And then the little indentation on the bottom, that's the negative terminal. Inside, so you've got this cathode. You also usually have around the edges of the battery an anode. That is the negative terminal. And it's usually made out of something like zinc. When the very first battery was created by Alessandro Volta in the, I think it was the early 1800s, he had zinc and silver next to each other, separated by little bits of paper. And so in between the cathode and the anode is this electrolyte. Maybe it's something like manganese dioxide or a mixture, something like that. And what happens is there's a chemical movement. There's a movement. They dance inside the battery. And the movement is electrons go toward the zinc or whatever it is. They go toward the anode. And so you get more electrons on the anode than you have on the cathode, and they come on out and they go around and they come out and they go around. So inside the battery, it goes from positive to negative, but outside the battery, it goes from negative to positive. So just a few more things and we'll be done with this video. You connect batteries in series if you want to add up the voltage. So as you pile on the batteries on top of each other, the volt amount goes up. So to generate a higher voltage, you connect batteries in series. Negative to positive, positive, negative to positive, negative to positive. This is called series aiding because by putting them in series, you're aiding the addition of voltage. If you put them in the wrong way, you put negative to positive and positive to negative, you would cancel each other out. That would be series opposition, and that would be pointless, wasting a good battery. If you connect batteries in parallel, that is where all the positives are connected to each other and all the negatives are connected to each other. You don't increase the voltage, but you do increase the amperage by doing that, and you increase the life of the battery by doing that as well, or you can increase the amperage. Submarines used to do this back in the good old days, but anyway, that was a long time ago. Now they use nuclear energy sometimes. Well, this has been our first video in the module on voltage, and we've talked a little bit about electromagnetic force.